Here we are in a little Google sheet, and I'm just going to talk about exponential growth. Imagine you have a bacteria. You have one bacteria, time is equal to 0 time t, time is 0, and we have one bacteria. Every single day it doubles, it reproduces, equals the one above it plus 1. Fill that down, Command D. I got a whole bunch of days here. This is going to be equal to the cell above it times 2. We're just doubling the number of bacteria. Let's fill that down. We have 1, 2, 4, 8, 16, 32, 64, and it's doubling each time. But I want you to notice you could also write that as 2 to this power, whatever this power is. So 2 to the power of t. When t is equal to 0, you get 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2 is 4. 2 to the power of 3 is 8. Let's just demonstrate that. So it's equal to 2 to the power of, so I just did the shift 6 to get the little chapeau, to the power of whatever this number is. We get exactly the same thing. What happens if we started off instead of with one bacteria? Let's say we started off with 5 bacteria. I'm just going to copy this, and I'm going to start off with 5. We're doubling the 5 with 5, 10, 20, 40. What could I have done to this column to have gotten that column? Like, what could I have done to the 1 to get 5, or the 2 to get 10, the 4 to get 20? Multiply by 5. This is going to be, I'm just going to copy that. Moving on over, fill that down. Just multiply these guys by 5, and I'm just going to copy this and say what we're really doing is we're doing this. 5 times our 2 to the power of t, like that. Let's just put a 5 here, so it's equal to 5. And then times, that's the little star, you find it on the shift 8. And let's fill this down, and notice we get exactly the same thing. 5 times 2 to the power of. I just want to point out that this 2, every time we're doubling, we're increasing what we had by 100%. We can break this down a little bit further. This is really 1 plus 100%, which is 1. If we wrote that, it's equal to 5 times 1 plus our 100% to the power of time. We get exactly the same thing. Why would it be to our advantage to break up that 2 into 1 plus 1? Because we're not always increasing by 100%. Things aren't always doubling. Let's say you had money in a bank account and that money was going up by 5% a year. Let's go and look at another spreadsheet. This is time. This is money. Let's say initially we have $1,000 in a bank account and that money is going up by 5%. This is going to be equal to whatever we had before, multiplying that by 5%, which is 0.05. Okay, but hey, whoa, so we got $50 now? Like we had 1,000 before, now we have 50, we have less? No, you still have the original 1,000. Really what we're doing is we're saying 5% of the 1,000 plus our old 1,000, the old amount, whatever we used to have. Something like that. This is going to be equal to that plus 1. We fill that down, it goes up. It's going up exponentially, not as fast as doubling, of course, but it's still going up exponentially. We start off with 1,000, now we have 1,600 for 10 years. If we fill that down, eventually we have 4,000, 25,000, 214,000. It just keeps going up. That formula that we were looking at before, we can use the same formula. I'm just going to go and copy that over here. Really what I'm after is something similar to this, but instead of the 5, I'm going to say, look, we're starting off with 1,000. It's going to be 1,000. 1 plus what we're increasing by now is 5%, 0.05 to the power of t. Let's see if that works. Equals 1,000 times 1 added to our percent, which is 0.05, raised to the power of time. If we fill that down, look at that, exactly the same thing. We get this nice formula. So this is our original amount, is $1,000. We're increasing by 5%, so we're going to expect 105% at the end of the year, raised to the power of time. How many years in this example? This is our growth and decay formula. The exponential function, we have c sub n is equal to c sub 0 times 1 plus I to the power of t. C sub n is the final value. Final value. So if you put money into a bank account, it's the money you get out at the end. C sub 0 is the initial value. If you put money in a bank account, it's the money you put in the bank account. Then the I is our growth rate or decay rate. This is the growth rate. If you put money in a bank account at 5%, this would be 5% as a decimal, so 0.05. You're going up by 1.05 is what this whole thing means. If something is doubling every so often, so it's going up by 100%. If you have a bacteria and every hour it doubles, it reproduces, this would be 100%. So altogether, this is 100% plus you get 200%, it's doubling. This whole thing would become 2 to the power of t. Whereas t is our time. T is time. Let's go and look at an example.